Now, let's move on to the next topic. Antimicrobial properties of crude extract from stingless bee honey against bacterial and fungal pathogens. Presented by Ms. Sumaiyah Mawing.
Okay, good afternoon, ladies and gentlemen. My name is Sumaiyah Mawing. Today I'm here to present about antimicrobial properties of crude extract from stingless bee honey against bacterial and fungal pathogens. First, let me giving you some background information. Honey is a natural sweetener produced by bee. Both honey and stingless bee honey have been used widely for medical benefits since ancient times. Several research studies have shown that bioactive molecules provide the honey to have abundance of biological properties such as antioxidant, anti-inflammatory, and antimicrobial. From that being said, there have been less extensively studies about antimicrobial properties in southern Thailand, especially in Narathiwat province. So the aim of our study was to investigate antimicrobial properties of 4 different ethyl acetate crude extract from stingless bee honey collected from Narathiwat province against 5 reference strains of microbial. They were Staphylococcus aureus, methicillin-resistant Staphylococcus aureus, Escherichia coli, Pseudomonas aeruginosa, and the Candida albicans. For the method, we use agave diffusion method with sample concentration 25% to 50% volume by volume. Firstly, we pick up a single colony of bacteria and yeast and transfer into the test tube containing broth. After that, we adjust the density of the cell into 0.5 McFarlane standard, 10 to 8 for bacteria and 10 to 6 for the yeast. After that, we swab the inoculum over the entire agar surface and then bore the well for each plate. After that, we add the crude extract 50% concentration at the first well and the second well for 25 concentration. And for the third and fourth, we add the positive and negative control respectively. And the last, we incubate the plate at 35 Celsius degree for 24 hours, and then we measure the inhibition zone created around the agar well, and then we record as millimeter. Here is our result. For the figure 1 is the example of our result, and as you can see, in every pathogen plate that we have tested, the first well create the zone of inhibition bigger than the second well. And this is indicate the concentration dependent of our crude extract. In the right side, we have table 1 and table 2 shows the inhibition zone in millimeter. And this is quantitative assay. So what I want to show you here is we use ANOVA test to compare the differences between the zone, and we focus on the differences between 4 extracts. And we found that in methicillin resistance S. aureus were significantly sensitive to S4 more than S2. P. aeruginosa sensitive to S4 more than S3 and S2. And for Escherichia coli were significantly sensitive to S4 more than S3 and S1. And for the table 2 is in the same way, and for the table 2, the result is the same way to the table 1. So we can conclude from this that sample 4 is the most effective extract against majority of pathogens we have tested. So for the discussion, for different samples we have potential against bacteria more than yeast, and for gram-positive bacteria more than gram-negative bacteria. And this might be owing to the structural differences between cell wall of them. Because of gram-negative bacteria, they have 3 layers of envelope, and they have the ability to protect cells from toxicity and microbial resistance and antibiotic resistance. For conclusion, For our crude extract, an inhibitory effect, could be a good source of novel naturally derived bioactive agent that may combat to multi-drug resistance in the future. Thank you for your attention.
Such an interesting presentation. Any question from our judges?
So can you explain a bit what are the differences between the four materials that you are using, S1 to S4?
Okay, thank you for your question. For S1 to S4, we have different species of stingless bee. And from the information that we have reviewed, the species of stingless bee can produce the different effect to inhibit the zone of emission, and its effect to inhibit the growth of the microbe.
Do you have a plan to identify the active compound of the honeybee?
Yeah. It's in our plan, but we want to test the minimum inhibitory effect of this before that.
Are there any other questions?
I have a question from Zoom. Can you hear me?
Yes, we can hear you.
What kind of pathogen you use? You use the reference strain from ATCC, or you use the clinical isolate when you tested all the microbial?
Okay, we use methicillin resistance as aureus here.
Yeah, because you mentioned that you use the reference strain for the pathogen, but you didn't mention the number of each bacteria and also the Candida albicans. So I'm not sure that you use the clinical isolate or you use the reference from the ATCC strain.
For S. aureus, Pseudomonas aeruginosa, E. coli, and Candida albicans, we use the reference strain.
Okay, not from the patients, right?
The reference strains,
Okay.
not isolate from the patient.
Okay, thank you.
Thank you.
Thank you, Ms. Sumaiyah.